We'll cast your mind back to February last year, and you may remember the excitement when NASA successfully landed its Perseverance rover. The vastness and infinity of space have long amazed and perplexed humankind. There's always been this nagging curiosity about whether or not we're alone in the universe and what mysteries might lie beyond Earth. Now, scientists from NASA have uncovered a surprising discovery. From a single huge deep space source, millions of radio messages are being delivered to Earth. What might they be, though? Do they have a natural explanation, or is there another explanation? Due to the unparalleled scale and coherence of the signals, scientists have more questions than answers. Could this point to the existence of sentient beings in other parts of the galaxy? What are they attempting to tell us if that's the case? Let's find out. Fast radio bursts may seem like an uninteresting event to some, but they have fascinated astronomers, physicists, and space enthusiasts. Their cryptic character adds to their attractiveness because there is so much about them that is yet unknown. Imagine the excitement among scientists when they first noticed several fast radio burst signals in a short period and continued to do so. Who or what is trying to get our attention, and what might they be trying to get from us? These are the questions we're left to wonder. Fast radio burst signals are radio emission bursts that last just a few milliseconds and are quick and intense. They possess the dispersion sweep characteristic of radio pulsars. After examining archived data, researchers learned that a pulsar scan of the Magellanic Clouds took place about 6 years before Duncan Lorimer discovered fast radio burst signals in 2007. The fact that fast radio bursts are also referred to as the Lorimer burst should not come as a surprise. When telescopes record a fast radio burst, scientists pay special attention to a feature known as dispersion. Dispersion is a measure of how dispersed a fast radio burst is when it finally reaches Earth. Instead of being empty, the expanse of space between stars and galaxies is filled with plasma, a soup of charged particles. As light moves through space, it comes into contact with many different barriers that might alter its path. A part of these barriers is plasma, which can slow down both radio waves and light. It's fascinating to observe that radio waves with lower frequencies are slowed down and influenced more than those with higher frequencies. A fast radio burst has several frequencies, and the dispersion effect happens when the higher frequencies reach Earth first. Scientists use this dispersion to determine how far away from Earth the fast radio burst source is. The signal has traveled through more plasma, with a higher dispersion indicating a further separation from the source. The first time a fast radio burst was discovered, it was situated near the Little Magellanic Cloud and resembled massive radio pulsar pulses. The restricted apparatus prevented a precise measurement of the signal's flow, though. According to researchers, there is a limited possibility of detecting the first fast radio bursts, which could happen in several hundred bursts per day. When the initial fast radio burst was found, scientists believed it to be a unique event because it only happened in 3 of the 13 beams of the Parkes multi-beam receiver. However, interest in the topic was renewed a few years later when a student named Sarah Burke-Spoler found another burst with a dispersion that was almost equal to that of the Lorimer burst. Fast radio burst signals were officially designated by Thornton and colleagues after they identified 4 additional Lorimer bursts in 2013. These bursts, which had substantially larger dispersion measures than the initial Lorimer burst, were discovered by high-time resolution universe surveys conducted with the Parkes 64M radio telescope. The brightest burst showed dispersion broadening with power law dependencies, as one would expect from alien radio emission sources. The first fast radio bursts found in a different observatory were announced in 2014, but their origin is still unclear, and scientists are still trying to identify it. Technological and methodological developments in research may help us comprehend these enigmatic bursts and their causes better. Researchers are keen to unravel this puzzling phenomenon. Hold on to your hats, people. The plot is about to get even more convoluted. After thoroughly analyzing their data, astronomers made a discovery in 2019 that would leave even the most experienced astronomer dumbfounded. The analysis showed that the fast radio burst's 121102 source broke the previous record for the most flares ever discovered from fast radio bursts, producing an astounding 1,652 flares in just 47 days. As a result of this new information, a whole new range of research possibilities opened up, and scientists raced to identify any kind of regularity or periodicity in the bursts. Sadly, they were unable to find any patterns. Their efforts were ineffective, and experts scratched their heads trying to figure out where the bursts came from. Because there was no periodicity, they admitted that it might be some time before we fully understand the enigma surrounding fast radio burst signals. Most fast radio burst sources only flare once before disappearing, making it considerably harder for scientists to forecast or find them. One of the few fast radio burst signals that have been observed to consistently generate signals is fast radio burst 121102, one of the most active fast radio burst signals. This strange object has been tracked by researchers all the way to a dwarf galaxy located 3 billion light-years away. But it's not your ordinary fast radio burst. It is quite congested and has only one pattern. After 90 days of activity, there are 67 days of silence. Due to the amount of activity it has seen, the 500M Aperture Spherical Radio Telescope, FAST, has been one of the instruments assisting astronomers in observing these bursts. Even during its testing phase, fast radio burst signals were detected by the telescope. In just 47 days, it gathered a staggering 59.5 hours of data in just 2 months, the highest level of activity ever observed in a fast radio burst source. The peak rate was 122 bursts in just 1 hour. Researchers conducted a statistical analysis of the source's activity. They categorized the bursts into higher energy and lower energy groups, each with distinct properties. It was demonstrated that the weaker bursts were more unpredictable. Despite their irregularity, scientists persist in their search for fast radio bursts. Through their investigation, they have discovered that although these bursts originate from galaxies millions or even billions of light-years away, they can release energy equivalent to hundreds of millions of suns in just a matter of seconds. The FAST telescope recently located fast radio burst 90520, a fascinating new one unearthed in China by researchers. This burst stands out because it repeats more frequently than others, releasing 75 bursts in just 6 months. To understand more, the team used the powerful Very Large Array Radio Telescope in New Mexico to concentrate on fast radio bursts. They eventually identified the mysterious signal's origin, a dwarf galaxy 3 billion light-years away. But they made an unexpected discovery. A weak radio signal was coming from the same area. This is an unusual find because only one other fast radio burst signal source is known to have a persistent signal. Using the position of the dwarf galaxy, scientists calculated its distance from Earth. However, an interesting disparity was found. The calculated distance, 30 billion light-years, was 10 times more than the real distance of 3 billion light-years based on the fast radio burst dispersion. This perplexing discovery raises more questions than answers. Could persistent radio signals be more widespread than we thought, and are they related to fast radio bursts? Scientists are determined to uncover more information about this peculiar phenomenon. With further research, we may unravel the mystery of fast radio bursts, leading to a deeper understanding of our universe. Despite considerable advancements in recent years, much remains unknown, but through cutting-edge technology and global collaboration, we continue our quest for answers.